We have two problems to solve to help us practice calculating solubility. This is actually stuff that's in both 17.4 and 17.5 together. And so the first problem we have on this worksheet is just asking us to calculate the solubility of calcium fluoride, which we have done an example similar to this already. So you already have seen one problem like this. This will be the second one that you see. With these problems, remember, we have to start by writing a balanced equation because we're going to need to make an ice table. And in our ice table, we don't know how much calcium fluoride we have. We don't have any products yet. The stoichiometry is 1 to 1 to 2. Let's take a look at where that 2 is coming from. And at the end, we still don't know how much solid we have. We have X calcium ion, and we have 2X fluoride ion. The solubility is asking us how much calcium fluoride dissolves. It's asking us how much dissolves, which is this number. And so if we can figure out one of these x's, we'll be able to figure out how much has actually dissolved. To solve for x's in these equations, we need to use an equilibrium expression, Ksp, which is going to be the calcium ion concentration times the fluoride ion concentration. Don't forget to square it because of that stoichiometry. And fill in what we know. We know the Ksp is 4 times 10 to the minus 11. The calcium concentration is X. The fluoride ion concentration is 2X, and that is going to be squared. So the right side of the equation is going to be 4X cubed. And now we need to solve for X. 4 times 10 to the minus 11 divided by 4, and take the cube root. X is 2.15 times 10 to the negative 4. Remember, the default unit on an ice table is molarity, or moles per liter. This problem wants solubility, which is grams per liter. So that means that we need to do a unit conversion, getting rid of the units of moles, converting into the units of grams for calcium fluoride CaF2. So I am going to look up CaF2 molecular weight, and it is 78 grams per mole. And I am now going to multiply our mole units cancel out, and we end up with 0.017 grams per liter. So let's take a look at what's next on the problem. Now it says to calculate the solubility of the same compound in a solution of sodium fluoride. And so we're going to do a recalculation this time. Now this is a problem that we haven't done anything like this before. All that we've done is talked about how would the sodium fluoride affect the solubility. So we're still going to use an ice table. We're making a new ice table because we have a new situation. The calcium fluoride dissociates into calcium ions and 2 fluoride ions. We're not concerned about adding or writing any kind of ice table for the sodium fluoride because that's not a solid substance that's not dissolving in water. So for the ice table, in this initial column, this is where we're going to have to think a little bit more because of the fact that this solution is being, or this calcium fluoride is being put into a solution instead of being put into pure water. So what we're going to do is ask ourselves, what does NaF have that might possibly be part of our equilibrium? Well, NaF dissociates to make sodium ions and fluoride ions, and we can see that NaF has fluoride, and so does calcium fluoride, CaF2. So that is the common ion between these two compounds. So we know that we are going to be starting this ice table with a little bit of fluoride that came from this fluoride ion dissociation from the NaF. How much fluoride are we starting with? Well, we are starting with 0.002 molar sodium fluoride, which means that we're going to be dissociating into 0.0020 molar sodium and also 0.0020 molar fluoride, because 1 to 1 to 1. So here we are starting with 0.0020. But we aren't starting with any calcium because we don't have an initial source of calcium, so it's still 0. And we still don't know how much of the solid we have. For the stoichiometry in the change, we have -x plus 2x. And when we get to equilibrium, we're going to have x calcium, and we are going to have 0.0020 plus 2x of the fluoride. But just like with acids and bases, we're going to assume that x is really, really small compared to 0.002. It's just not going to matter anymore. So again, this problem wants us to figure out how much calcium fluoride dissolves, and if we can solve for x, we'll know the answer to that question, which means we need to write an equilibrium expression, Ksp. It's going to be calcium ions times fluoride ions. Don't forget to square them. Squared. We know the Ksp. Let's go looking for it. The Ksp is 4 times 10 to the minus 11. 4 times 10 to the minus 11. The calcium ion is represented by X. The fluoride ion is represented by 0.0020. Do not forget to square it. Now we need to solve for X. 4 times 10 to the minus 11 divided by 0.002 squared gives us an X of, feel like I definitely did something incorrect there. I need to try that again. 4 times 10 to the minus 11. I'm going to do this one more time because I'm getting really, I feel very untrustworthy, or my calculator is very untrustworthy. 4 times 10 to the minus 11 divided by 0.002 squared. Okay. Got the same answer 2 times in a row, so it must be right. And remember that these are units of molarity, because the ice table will always give us units of molarity unless we have set it up differently. The problem is asking us for solubility, not molar solubility, which means that we want to get out of the units of moles and into the units of grams, and let's go find the molecular weight. We already used it. The molecular weight was right here, 78 grams per mole. And so our answer is 7.8 times 10 to the minus 4 grams per liter. The mole units cancel. Did our solubility go down? Well, we started with a solubility of 0.017, and then when we had a common ion present, our solubility dropped a lot. So that answer makes sense with what we were just talking about conceptually in the last video.